Welcome back to Upgrade to General, a series to help you upgrade your amateur radio license to General class. This episode is Sub-Element G6, Question Group A, about electronic circuit components. And I'm your host, Ron Call, KE7CR. Let's jump in and get started. This question set, unless you've had some background in basic electronics, is going to be a lot of memorization. If you've had some background in electronics, you'll still have to recall a lot of specific details. So I'll just go through each of the questions with you and refresh your memory. First question asks, what is the minimum allowable discharge voltage for maximum life of a standard 12-volt lead-acid battery? And the answer is 10.5 volts. If you discharge below that level, it can cause changes in the chemical nature of the lead-acid cell, which is not reversible. So it will damage and destroy the cell. The next question, what's an advantage of batteries with low internal resistance? Remember, every battery is going to have some resistance to it. That internal resistance of the battery will affect how it operates in the circuit. The less internal resistance you have, the higher the current can be drawn from that battery. So the answer is high discharge current. The next question, what is the approximate forward threshold voltage of a germanium diode? Now here you're just going to need to memorize. Germanium diodes, it's 0.3 volts, 300 millivolts. And for silicon diodes, 0.7 volts or 700 millivolts. And that's another question. What is the approximate forward threshold voltage of a silicon junction diode? 0.7 volts. The next question, which of the following is characteristic of an electrolytic capacitor? Electrolytic capacitors look like the little round soda pop can looking capacitors. The advantage they have is high capacitance for their given volume or size. The next question asks, why should wire-wound resistors not be used in RF circuits? Wire-wound resistors act like an inductor. They're a coil of wire, so they generate a magnetic field, and the inductance of that magnetic field can affect the circuit. So the answer is the resistor's inductance could make the circuit performance unpredictable. The next question, what are the operating points for a bipolar transistor used as a switch? Transistors are often used as either switches in digital circuits or linear amplifiers in analog circuits. So for a digital switch transistor, the two features or points you need to pay attention to are the saturation and cutoff. The saturation is essentially the full on position, and the cutoff is the full off position. So that's the answer to this question, saturation and cutoff. Another question, which of the following is characteristic of low voltage ceramic capacitors? Ceramic capacitors are these kind of disc looking capacitors, flat, often round. The real advantage of those is that they have a comparatively low cost. They're inexpensive relatively. So the answer, comparatively low cost. Another question, which of the following describes MOSFET construction? M-O-S-F-E-T. MOSFET stands for metal oxide semiconductor field effect transistor. And they're constructed so that the gate is separated from the channel with a very thin insulating layer. That way you get better current flow between the drain and the source, but not through the gate. And it makes these transistors excellent. Now, we don't see a lot of vacuum tubes in radio operation anymore, but some of the older gear, a lot of restoration gear, people still use vacuum tubes for that. So there's a couple of questions in this question set about vacuum tubes. One of them says, which element of a vacuum tube regulates the flow of electrons between cathode and plate? That's the control grid. Another question about vacuum tubes says, what is the primary purpose of a screen grid in a vacuum tube? You can have more than 3 components in a vacuum tube. Typically the cathode, the grid, and the control plate, but the screen grid reduces grid to plate capacitance. Remember, a capacitor is just any 2 metal plates or metal pieces separated by some kind of an insulator. In this case, in a vacuum tube, it'd be space, a vacuum. So you're going to have a capacitive effect from the grid to the plate. But by putting a screen grid in between them, that reduces the grid to plate capacitance. The last question asks, what happens when an inductor is operated above its self-resonant frequency? Remember that an inductor is just wire wrapped around something, coiled up. Could be coiled around air or another material, and that AC traveling through that conductor is going to create a magnetic field, an inductance. But remember, say for example you have a couple of turns of wire in this coil. They're separated from each other by a little space. Well, you've got metal, a space, and metal. That's exactly the definition of a capacitor. Now, typically an inductor is going to be operating at a frequency that the inductance is what generates. You're going to have a magnetic field generated, an inductance. But at a specific frequency, that inductance will be overcome by the capacitance. So that's called the self-resonant frequency of that component. And you're going to have that inductor no longer be an inductor, it's going to be a capacitor. So the answer to this question is, it becomes capacitive. So remember that any component needs to be operated within the manufacturing specifications of that component. So if you're using an inductor for the inductance that it has, remember to operate it below the self-resonant frequency. Thank you for joining me for this question set. Look forward to seeing you in the next one. This is KE7CR 73.